Okay, let's look at this example of a net present value. We're asked to solve for the net present value of a project. And so we have some company, they have a special investment. They have a project that needs 2 machines, 25,000 for one, 10,000 for the other. Both machines are required. We're not comparing 2 different machines. The total residual value is 1,000 at the end, and it's going to generate $11,000 of cash inflows over its 10-year life. We can solve this using time value of money tables, which I will show you here, or Excel, which I will also show you here, if that is made available to you for your instructor. If you are taking this exam in the online testing center, unfortunately, Excel is not available for you there. Okay, and this company has a 6% return. So if they require a 6% return, what's the present value of the table? So I'm going to set this up in a table format, and this is exactly how I would recommend that you do it. We have an initial investment, we have cash inflows, we have a salvage value. I've written the amounts out, and the signs matter. So the outflow, the initial investment is an outflow. It's minus 35,000. That's the 25,000 plus the 10,000. We have annual cash savings of 11,000. That's an inflow. We have a salvage value at the end of the 10 years. That's an inflow. When do these things happen? The initial investment happens now. The cash flow inflows are years 1 through 10. That's how we know it's an annuity. It's a constant number over time. And the salvage value happens one time. That's in year 10. The present value of any dollar today is $1, so the present value factor is 1. So we know the present value factor, or excuse me, the present value of the initial investment is minus $35,000. Okay, so using the tables, and you probably just be given this information, the present value of an annuity of $1 at 6% for 10 years is 7.360. This is an annuity, the cash flow that happens over and over and over. So I'm going to put that factor in 7.360. The present value of $1 or a single sum at 6% for 10 years, 0.558. This is a one-time amount. It happens at the end of year 10, 0.558. Now I just extend out the math. So my present value of the cash flow for my inflow is the 0.736 times 11,000. And my present value of the salvage value is 0.558 times 1,000. And then I sum these 3 cash flows to net them to get net present value of 46,518. Meaning this has a positive present value, and so it's something that they should do. I'm also going to show you how to do this in Excel. So the Excel formula for the present value of the cash inflows is going to be PV, open parentheses, 6%, comma, 10, comma, that's the number of years, minus 11,000, that's the reoccurring payment, minus 1,000, that's the cash flow, the salvage value at the end. And the way I usually set up the formula when I use Excel is I take the initial investment, which is already at its present value, and I compare it to the present value of the cash inflows to get the net present value. And in this case, I think we have a difference of 1. Yeah, we have a difference of 1. And actually, this is the more accurate of the two because the tables, round a little bit. Excel doesn't round. So, and then how did I get the 81,519? It is literally this formula right here. So let's look at this net present value question. The fun part is evaluating a new game. They've narrowed it down to Wacky Water Race Game and the Whack-A-Mole. Here's the information about the Wacky Water Race Game. The initial investment is $31,000. It has a net cash inflows of $8,000, and we expect that to be consistent every year for 6 years. And at the end of the 6 years, we think it's going to have a salvage value of $3,000. You can solve this using time value of money tables. I'm going to show you how to do that. or Excel. I'm going to show you how to do that too. If that's going to be available to you. If you're taking this exam in the online testing center, then it is not available to you. Assume that they have a 4% required rate of return. So the first thing is I'm going to set up this table, and I recommend this is how you should do it. Put something like this in your notes so you remember how to do it. We're going to take the initial investment of minus 31,000. That happens now. So the present value of $1 today is 1. So the present value of 31,000 is 31,000. Since this is an outflow, it is a negative 31,000. And now we need to find the present value factor for the annuity and the one-time amount. The present value factor of the annuity at 4% for 6 periods is 5.242. And so I plug that in here. The present value of $1, which is a one-time amount at 4% for 6 periods, is 0.79, and I plug that in here. I then extend these out, multiply them out, right? I take 5.242 times the 8,000. I take 3,000 times 0.79, that's where I get these numbers, and then I sum them. I net them, basically, right? So that's how I get the net present value of 13,306. We can also do this in Excel. The Excel formula is going to be PV open parentheses 4%, 6 number is the period, minus 8,000 is the payment, and minus 3,000 is the one-time amount salvage value. That's the formula I use to come up with the present value of the cash inflows. So I take the initial investment, which is already at its present value, minus 31,000. I compare that to the present value of the cash inflows, 44,308, and I get net present value of 13,308, which I think was $1 different than the other way. And this is actually the more accurate of the two. All right, let's look at this net present value question. So this company is evaluating the purchases of a new computer network, and here's the information, right? They have initial investment of $24,000. That happens now. There's net cash inflows of $8,500. This happens for 5 years, each year for 5 years. And then there's salvage value of $2,000 at the end of 5 years. We can solve this with the time value of money tables, which I'll show you how to do in this video, or Excel, which I'll also show you. And you can use Excel if that's made available to you by your instructor. If you're taking this exam in the online testing center, then it is not available to you. And let's assume there is a 12% required rate of return. So again, I lay out the information in this table, and this I think is the easiest way to do it. So I have 3 cash flows: initial investment, that's minus 24,000. That happens now. The present value of $1 today is $1, so the factor is 1. So 1 times minus 24,000 is minus 24,000. I need to find the factor for the cash inflows. This is an annuity. It happens every year for 5 years of $8,500. And I need to find the factor for the salvage value of $2,000 that happens at the end of 5 years. So the present value of an annuity for 12% for 5 periods is 3.605. So I plug that number in there. The present value of $1, 12% for 5 periods is 0.567. So I plug that number in there. Now I just extend out the math. So 8,500 times 3.605 is 30,643. 2,000 times 0.567 is 1,134. I sum these, or net them together, to get net present value of 7,777. I can also do this in Excel. The Excel formula is PV open parentheses 12%, 5 periods, minus 8,500, that's the payment, minus 2,000, that's the future value. And then I usually have this little table when I use Excel. So the initial investment is minus 24,000. The present value of the cash inflows, 31,775, and that number is this formula. And then of course I net those together to get 7,775, so it's slightly different than the other one, and this is actually the more accurate of the two.